Have you heard of the Cybertruck? Of course you have. It is well known that this vehicle is revolutionary in a way that is reshaping the industry, yet no one seems to be talking about it. There are truly incredible synergies and cost savings being produced by the partnership between SpaceX and Tesla that no other automaker can match. Welcome to Only Pay, in which we explore the world of Tesla's success and its ongoing pursuit of creative solutions based on first principles. 2015 saw Tesla hire Charles Cuman, a brilliant alloys specialist with a PhD in material science and engineering who had previously worked at Apple and SpaceX. Before we begin, be sure to subscribe to Only Pay. With that said, let's begin this video. Cuman brought a wealth of knowledge and experience to the table, and Cuman's knowledge has found its way into the Cybertruck in ways that will forever change the automotive industry. For the time being, let's ignore the 8,000-ton Giga press for the Cybertruck's rear body. Yes, it's a big deal, but today we're focusing on one aspect of the Cybertruck that has an indirect impact on the SpaceX Starship. It's something that exemplifies how innovative Tesla is. The key to Tesla's success is its commitment to original thought, constant improvement, and adoption of fresh concepts. Charles Cuman, a specialist in alloys who previously worked for Apple before joining Tesla and SpaceX, was hired by Tesla in 2015 and is now the head of materials engineering at both organizations. A few months ago, we learned that Tesla signed a supply agreement with Steel Dynamics for the Cybertruck. Cuman received his PhD in material science and engineering from Northwestern and co-founded Questac, a company that developed and commercialized numerous new materials, engineering tools, processes, and alloys. He later served as Apple's head of product design for 3 years before joining Tesla. The largest slitting line in North America will be installed and run by Ferris 85, FBI's new factory in Sinton, Texas. The slitter is capable of producing slit wet steel, and Steel Dynamics has a new electric arc furnished steel mill under construction and sent in Texas that will supply steel to Tesla. The EAF method is responsible for making about 25 of the world's steel using high current electric arcs to melt steel scraps and convert them into liquid. Just as Tesla designs its Hardware 3 and Hardware 4 full self-driving chips in-house but outsources their manufacturing, it is developing its alloy but will need to develop new manufacturing techniques to use it. With the new stainless steel alloy from the Cybertruck, a similar situation occurs. The distance between Giga and the SDI factory in Sinton, Texas is 3 hours. Texas and Austin are home to the secret to Tesla's hegemony. Elon Musk claimed that the ultra-hard 30x cold-rolled stainless steel proprietary alloy was the key, and it was capable of shattering a stamping press. Because it cannot be stamped like conventional steel, this special alloy is the reason for the distinctive planar design of the Cybertruck. So let's go into more detail. In his response to Viv, Elon Musk makes an intriguing revelation. The new steel alloy was first used in SpaceX's Starship spacecraft before being used in their Cybertruck. Elon explains that Tesla had originally intended to use stainless steel skins for the Cybertruck because titanium skins proved to be much stronger. However, there is more to this decision than meets the eye. Elon's true intention is to create greater demand for the alloys that SpaceX ultimately settles on increasing production volume and driving down the material cost. It's important to keep in mind that the demand for alloys in space applications differs from that of Earth, where rust prevention is the primary concern. Despite this discrepancy, alloys must endure intense heat during re-entry into the Earth's atmosphere. Given that SpaceX is continuing to experiment with different materials, it wouldn't be surprising to see Tesla follow suit with the Cybertruck. Tesla's commitment to constantly developing materials is demonstrated by Elon's statement from last summer. In contrast to traditional automakers who stick with materials and designs for decades, Tesla rapidly changes alloy constituents and forming methods, making traditional naming conventions like 304 less relevant. Tesla is constantly improving and implementing new technologies in order to benefit the average consumer. The company thrives on continuous research and development. One of the remarkable qualities of the Cybertruck is its extraordinary resistance to dents, scratches, and rust. Since rust is a bigger issue than most people realize, let's define the 304L and 30X cold rolling alloys. Let me give you the main talking points and important takeaways when Elon Musk refers to stainless steel as ultra-hard some sheet metal, even though I could delve into this subject for hours. Although strong in terms of strength or yield strength would be the appropriate engineering term, engineers might object. Although Elon is aware of this, he also recognizes that the typical Tesla supporter might not be familiar with a yield strength. The notion of yield stress or yield strength, the critical point at which a material starts to deform plastic behavior, describes a material changing permanently in shape as a result of external forces. Now let's dive into the intriguing story behind the 30X and its meaning, thanks to the inquisitive mind of Thomas Bradford, who received an answer near the end of 2019. He had posed a question to Elon Musk wondering if the 30x referred to the alloy type with x representing an unknown variable such as 303 or 304, and that the yield strength determined the maximum load or upper limit of the force that could be applied without causing permanent deformation or altering the shape. Elon replied admiringly, praising the question and explaining that it was a new variation of the 300 series stainless steel that underwent a number of cold working processes depending on the kilotonnage of pressure used at the time. The precise composition was not 303 or 304, but rather an innovative series that repeatedly experimented with cold pressing. The 300 stainless steel series is a genuine member of the family of alloys known for its durability and affordability. Elon specified that the alloy would be 3 millimeters thick or roughly 0.118 inches. This comparison of door thicknesses demonstrates that the steel in Cybertruck's doors are 3 times thicker than the majority of other door panels. Ostentitech stainless steel, of which the Cybertruck's alloys is a part, is non-magnetic but can acquire slight magnetic properties through cold working or cold rolling the 300 series. Steel has a crystal structure that can be either face-centered, cubic, or body-sensor Cuban when heated or subsequently cooled. Elon also briefly touched on the meaning of L in this context in a previous tweet. For example, 304 stainless steel has a maximum carbon content of 0.08%, whereas 304 liters has a maximum carbon component of 0.03%. Despite 304's structural weakness compared to 304, its lower carbon content proves advantageous. Pages should be thinking about the stainless steel series types because they are expected to last in corrosive environments and during the welding process. Similar to battery chemistries, each has advantages, disadvantages, and trade-offs. Elon's final indication made reference to the specific series of stainless steel's 304, but it's crucial to remember that this will be a proprietary alloy, which means Tesla and SpaceX won't use any of the conventional 300 series alloys. Despite the lack of specifics, we do know that the alloy will go through a number of processes. Hot-rolled steel is compressed between a number of power rollers during the work hardening and finishing process known as cold rolling to create stronger and thinner steel sheets. Contrary to popular belief, cold-rolled stainless steel is very suitable for applications requiring high precision strength and superior surface characteristics. When pressure is applied to hot-rolled steel, the crystalline structure becomes elongated and dislocated along the direction of the roll, which effectively increases the material's yield strength. Remember how Ferris 85 supplied hot-rolled steel to Tesla. Cold rolling does not involve layering. Instead, its main goal is to maintain tight tolerances in thickness, flatness, and uniformity throughout the process. Let's clear up a common misunderstanding. We don't need to emphasize the alloy's ability to withstand 30 rounds of rolling or boast about it being 30 times harder. Yes, theoretically, it's possible to push the limits, but practically speaking, it just doesn't make sense. Cold rolling comes after hot rolling and produces steel with improved resistance to tension breaking and deformation. We don't want to compromise the integrity of the material because tolerances don't magically get better with more rolls. In fact, internal stress increases with each roll, which isn't even what Elon Musk had in mind when he introduced this innovation. Elon Musk's real discovery is that this extremely hard 30x steel cannot be easily stamped or bent. Instead, it requires a deep score on the interior, which is how the impressive Cybertruck prototype was made. This is where the magic happens to create the body panels for the Cybertruck. Tesla uses a cutting-edge procedure to reduce forming operations. Instead of using traditional stamping, laser cutting ensures accuracy and efficiency. Elon Musk personally displayed the Cybertruck's incredible toughness in mind-blowing videos in which the skin withstood sledgehammer strikes at point-blank range and 9mm full-metal jacket bullets fired from just 10 meters away. The road ahead is paved with exciting possibilities like this video. If you found it enlightening, consider subscribing for more mind-blowing Tesla content, and keep in mind your next adventure awaits. Have a fantastic day ahead.